Welcome back. In this short lecture, we will see operator precedence and association. It is one of the most important topics and people make mistakes in solving equations containing multiple operators. But if anyone knows operator precedence and association, then there is no chance of making any mistakes. Let us see operator precedence and association table. Over here, operator at the top has got higher precedence than the operators at the bottom. First come postfix operator. This is post-increment operator and post-decrement operator. Then comes prefix, unary and logical not operator. Then we have multiplication, division and modulus operator, which is followed by addition and subtraction. Then we have set of relational operators, less than, greater than, less than or equals to, and greater than or equals to. Then we have equality operator, double equals and not equals. This is bitwise and, bitwise exclusive or, bitwise inclusive or, logical and, logical or, ternary or conditional operator, and finally we have set of assignment operators: equals, plus equals, minus equals, multiplication equals, division equals, and remainder equals. Associativity is another aspect of all the operators. Now, to understand the meaning of left to right and right to left, let us see an example. Consider this simple equation: 10 minus 5 minus 5. What do you think? What will be the result? Will it be 0 or 10? Let's see. Now here we have minus operators and no other operators involved. So there is no question of precedence in this case. Now let us check the association of minus operator. It is from left to right. So to solve this equation, we will start from the left side and move towards right. Starting from the left side means we will start grouping from the left hand side and we will move to the right. So let us group this equation. So we will group like this: 10 minus 5, we will group it first, and then minus 5. And now we will group the right operator. So we will group this. Now to solve this equation, we will solve the inner bracket first. So inner bracket is this one. And this will become 10 minus 5 is 5 minus 5, which will become 0. So the answer is 0 and not 10. Had minus operator been right to left associative, we would have grouped as follows. Consider the same equation: 10 minus 5 minus 5. If it were right associative, so we would have grouped this one first and then move towards left. Now to solve this, we need to solve the inner bracket first. So this equation would have become 10 minus 0, which will become 10. So in this case, answer would have 10. So when you solve an equation which involves multiple operators, don't just follow precedence. Keep in mind the operator association as well. Let us see some examples of operator precedence and association. In this example, we have 4 equations. First one we had already seen. Output was 0. This is the second equation. This is the third equation. And finally, we have the fourth equation. Let us check the output of all the equations first. So the first output is 0. Output of second system.out.println is 397. Let us write it over here, 397. For the third equation is minus 1. And for the fourth equation is, this is true, and value of A is 3. Let me save it. Control S. Now let us solve these 3 equations one by one to understand precedence and association. We are going to first solve this equation. Let me rewrite this equation. Now to solve this equation, we need to group the operators based on precedence and associativity. Let us see how many operators are there. So this is assignment operator, this is pre-decrement operator, binary plus, post-increment operator, binary plus, post-decrement operator, binary plus, and post-increment operator. From the operator precedence table, postfix operator has got higher precedence. So we will first group the postfix operators. This is post-increment operator, post-decrement operator, post-increment operator. Then comes prefix operator. I'll group prefix operator. Now I'm left with 3 plus operators. Now in this case, to group, associativity comes into picture. plus operator associativity is from left to right. So we'll start grouping from left and then we'll move towards right. So this is the leftmost plus operator. We'll group this first. Again, I'm left with two plus operators. This is the left one. So I'll group this first. And you can stop when you are left with only one operator in the outer equation. So this is my equation and this is the only operator I'm left with. This is a binary plus operator. This has got two operands, one at the left and one to the right. There is one more thing you need to remember. To solve any binary operator, we solve the left hand side operand first, then the right hand side. So we will solve this side first. Now if you consider this side has got one binary plus operator. So this is the right side and this is the left side. Again from this left side, we have got this plus operator. This is the left side and this is the right side. So we are going to start from here. Before we start, let us first draw the memory map for A. So this is integer type memory location. Its name is A and the initial value is 100. Let us solve this equation now. So we'll start from here. Minus minus A. This is a pre-decrement operator. We need to first decrement the value of A in the memory. So we'll decrement it by 1. It will become 99. Now use it in the equation. Two brackets and then this bracket we are solving now. 99 plus the right hand side of this binary operator. So right hand side is A++. A++ is post increment operator. So first use the value of A in the expression. So 99. Then go and change it in the memory. So A will become 100 now in the memory, but in the expression we have used 99 plus A minus minus plus A++. Let us move ahead. 99 plus 99 equals to 198 plus A minus minus. Now what is the value of A? Current value of A is 100. This is a post decrement operator. So first use the current value of A in the expression or equation. So A is 100. Then decrement it in the memory. So A will become 99 plus A++ equals to, this will become 298 plus A++. Now the value of A is 99. It's a post increment operator which says use it first in the expression and then go and change in the memory. So A will become 100. So this equation will become 9, 8, 17, 7, 1, 9, 9, 18, 19, 9, 1, 2, 1, 3, 397. So this is A equals to 397. Now this is assignment operator which says assign this value to A. So current value of A is 100. Go and change it to 397. So if I say system.out.println A equals to, so this will print A equals to 397. Let us verify this output in Eclipse. Over here A is 397. Let us now solve the second equation. Let me rewrite this equation as well. Memory location of A is of int type. Name is A. The initial value is 1. Let us now check various operators in this equation. So this is assignment operator. This is unary minus operator, post decrement operator, binary plus, post increment operator, division operator, unary minus, post decrement operator, multiplication, and pre-decrement operator. Now based on this table, let us now group all the operators. So we need to group postfix operator first. So this is post decrement operator. So we'll group this one first. Then we have post increment operator, post decrement operator. Then we have set of prefix and unary. These are at the same level. So we'll start grouping unary operator and prefix operator. So we'll group this one. This one is also unary operator and this one. Now in this equation, we are left with three operators apart from assignment operator. This is binary plus, division and multiplication. Now division and multiplication have got higher priority than binary plus, so we will group these two operators first. Now these two operators are at the same level, multiplication and division. So to group these operators, we will check the associativity. Now its associativity is from left to right, so we will start from the left hand side. This operator is at the left in the equation and this is at the right, so we'll group the left operator first. So I'm going to group it first, and then finally I'll group multiplication operator. Now this equation has one binary operator. The left hand side is this one and this one is the right hand side. So to solve this equation, we'll start with left operand. Equals the inner bracket first. The value of a is 1. It says a minus minus. So post decrement operator, first use the value of a is 1, and then go and decrement it in the memory. So a will become 0. This is minus 1. Now we have solved the left hand part. We'll move to the right hand part. Now the right hand part has one multiplication operator. This has got this left hand side and this right hand side, so we will solve the left hand side first. Now in the left hand side we have another binary operator, division, which has got the left hand side and the right hand side, so we will solve this side first. First bracket, second bracket, we are going to solve the third bracket. A plus plus. Now the value of a is 0, current value is 0. It's a postfix operator, so which means use the current value in the expression. Use 0 and now increment the value of a by 1 in the memory. So we'll increment it. A will become 1 divided by outer bracket. We'll solve the inner bracket first. So minus value of a, current value of a is 1. This is a post decrement operator. So first use the value. So we'll use 1 and then go and decrement the value of a in the memory. A will become 0. Is minus 1 and this one, this bracket, multiplication operator, minus minus a, semicolon, minus 1 plus 0 divided by minus 1, which is 0, multiplied by, anything multiplied by 0 will be 0, but we still need to solve this part as this is not a short circuit operator. This is a pre-decrement operator. It says first go and change the value in the memory. So I will decrement it by 1 in the memory. This will become minus 1 and now use it in the expression. So it says minus 1, it says equals to minus 1 plus 0 multiplied by minus 1 is 0, equals to minus 1 plus 0 is minus 1. So this equation says a equals to minus 1. Now this means assign minus 1 to a. This will override the current value. Even though the current value is minus 1, but it is going to override it with the new value, minus 1. So this is statement system.out.println is going to print minus 1. A equals to minus 1. Let us verify this in Eclipse. So the result is minus 1 and the output is a equals to minus 1. Let us now solve the last equation. This looks like a very complex equation, but this is easiest of all three. Let me rewrite this equation first. In this example, we have two variables. First one is of int type. Its name is a. Initial value is 2. Another one is of Boolean type. Its name is res. And it will store the result of this equation. So now let us see how many operators are there. First one is assignment operator, then we have a postfix operator, or this is double equals operator. Then we have logical or, prefix operator, double equals, logical and, prefix, double equals. So there are so many operators. Now based on the precedence table, we will group all the operators. Postfix has got higher priority, so let us first group postfix operator, a++. Then we have got prefix operators. Let me group prefix operator. Double equals operator has got higher precedence than logical and logical or. So we'll group double equals operator first. Logical and has got higher precedence over logical or. So we will group logical and first. And now in this equation, I am left with only one binary operator. So this is the left hand side and this is the right hand side. To solve this equation, we'll start from the left hand side. Equals to a plus plus value of a. This is a postfix operator. So first use the value of a in the expression. It's 2. Now go and change it in the memory. A will become 3. Double equals 2. And we have the right hand side. Two double equals 2 is true or right hand side. Now this is a short circuit operator. So if the result of first operand is true, whatever be the result of second operand, be it true or false, the final result will always be true. Now as this is a short circuit operator, so Java runtime will not evaluate the right hand side. It will just leave the right hand side and will return you the result. That means res equals to true. This means this is an assignment operator. Assign true to res. So we'll assign true to res. So this statement will print res equals true, and this will print value of a, which is 3. So the output will be true and 3. Let us verify this output. So res equals to true and output is 3. To get hold on this topic, I would suggest to write some random expressions using various operators in Eclipse and find out the output. You can test the output by executing your programs. This will help you to completely understand operator precedence and association table. With this, we have come to an end. See you in the next lecture. Till then, happy coding.